Good afternoon, dear students. Hope you're all doing well. Okay, today I thought of sharing few things on a topic which we have already discussed in the previous semester. So in today's lecture, we'll be discussing about the dispersed systems. Hope you remember what are dispersed systems, right? So dispersed systems are the dosage forms which have two different phases, dispersed phase and dispersion media. So we have seen in detail about two types of dispersed systems like suspensions and emulsions. In the previous semester, we dealt with the different, uh, you know, how can we prepare suspensions and emulsions and what are the actual stability parameters of suspension. How can we improve the stability of a suspension? Whereas in today's lecture, we'll be discussing about emulsions. How can we improve the stability of an emulsion? And what are the various instability parameters of an emulsion? That we'll be discussing in this lecture. Before we get into this, we'll be discussing about a few basics. We'll be just brushing up few basics. Let's see the definition of an emulsion. Emulsion is a thermodynamically unstable system which has two immiscible liquid phases which are dispersed one in each other by means of emulsifying agent. Here the emulsifying agent acts as a barrier between the two phases, the oily phase and the aqueous phase, and thus helping the oil globules not to fuse with each other, right? So this is the basic definition of an emulsion. Before we get into the stability considerations, we need to remember the theories of emulsification. Now, do you remember theories of emulsification? How many theories at least? Enough think for at least a minute. What are the various theories of emulsification? How many theories? First of all, there are three theories of emulsification, right? And what are the different types of emulsifying agents and how they are classified? Remember? Try to remember at least one or two examples apart from your egg yolk, milk. So you're having actually a good number of emulsifying agents that are used for pharmaceutical purpose, right? Now we'll be just discussing about in brief about the various theories of emulsification. I'll not take much of the time in discussing about the theories, but our aim is to focus on the instability parameters and how can we encounter those instability problems during the formulation of an emulsion. But before we get into that, we need to brush up the basics, right? Now, let's discuss about the theories of emulsification. We are having three different theories of emulsification. The first one is monomolecular film theory, where the name itself indicates the emulsifying agent once added in the formula, it forms as a monomolecular layer at the interface. Now, these theories of emulsification is based on how the emulsifying agent acts, and based on the mechanism of its action, based upon the mechanism of emulsifier, how it acts, we're having three different theories. If the emulsifying agent that has been added, it forms a monomolecular film at the interface of oil and liquid, then the theory is known as monomolecular film theory. And if it And if those agents they form multi-layers molecular films, it is known as multi-molecular film theory. Right? And if the added emulsifying agents they form as particulates at the interface, it is known as solid particulate film theory. Solid particulate film theory. So based on how the emulsification or emulsifying agent act, we're having different theories. Now based on how they form different films at the interface, we are having different classification of emulsifying agents. We are having three different types of emulsifying agents. The first one is surface active agents. Surface active agents, they get aldehyde at the interface, form a monomolecular film. And the agents which form multimolecular layer, they are categorized as hydrophilic halides. They form multimolecular film at the interface. And finely divided solid particles, they form as a particulate film across the interface. The main aim of the emulsifying agent is just to act as a barrier between the two different phases, right? How they act is the actual story behind the theories of emulsification. Now we understood, right? So based on the theories of emulsification, how the emulsifying agent acts, we are having three different categories of emulsifying agents. So this is about theories of emulsification and the classification of emulsifying agents. Now let's see the classification of emulsifying agents. All the emulsifying agents, they actually get adsorbed at the interface, oil-water interface. The surfactants, they form monomolecular film. Hydrophilic halides, they form multimolecular film around the globules or the droplets. Finely divided solids, the name itself indicates, they form a film of the particles or the particulate film. Now, you need to actually go through the examples of all these categories. So before we get into the stability considerations, I would like you to remember our experiment, which we have done in our practical session. The experiment is the preparation and evaluation of an emulsion. Hope you remember that. You have taken your oily phase in a separate dish. You have heated it up to 70 degrees centigrade, right? And you have taken the aqueous phase in another beaker. You have heated up to 70 degrees centigrade. You have mixed both the phases while maintaining the temperature of 70 degrees centigrade with constant continuous stirring till you get a creamy consistency. Hope you remember that experiment. Now, what did you do after preparing the emulsion? It's not just the preparation, right? In the last semester, you have prepared the emulsion, and this semester, you have prepared and you have even evaluated the stability of an emulsion. How did you perform? Do you remember something? Or which parameter you have considered while evaluating? And most of the students, they got a stable formulation for which they'll be not getting any, it's not necessary for them to evaluate because they did it perfect. But you need to know what are the various instability problems that you will be encountering while preparation of an emulsion, right? Now let's see what are the different parameters that we need to consider. So when we are preparing an emulsion, we need to consider four main reasons for the instability. The first one is the flocculation and creaming. Second one is coalescence and breaking. Third one is the physical and chemical changes. Fourth one is the phase inversion. Now let's see one by one in detail. Before that, let's see a chart which shows the physical instability of emulsion. So when we look at the chart, this is the good emulsion where the two different phases are dispersed uniformly, right? We are able to see oil droplets dispersed in the aqueous phase. These globules or droplets are not fused together, they are evenly dispersed now. Because of various reasons, it could be the wrong choice of emulsifying agents, or it could be changes in the temperature, or any errors during manufacturing process, or not maintaining the sufficient ratios of internal phase and external phase. These could be various reasons that lead to physical instability. And when we look at the chart, we are able to see coalescence is the formation of larger droplets. They are fused large instead of uniformly sized to smaller droplets. It leads to larger droplets. In the coming slides, we'll get to know what is the reason behind this one. The second cause of instability is the flocculation. The name itself indicates all the globules or droplets will come together to form as a group, flocks. So this phenomena of formation of smaller flocks is known as flocculation. Another phenomena is these floccules, they will tend to come closer and they form as a layer. This phenomena is known as creaming. And when this is left as such unnoticed, this will lead to complete separation of two different phases called breaking. So these are the various physical instability problems of emulsions. Now let's see one by one in detail. Now let's see the first instability parameters. In this, we'll be discussing about flocculation and creaming. Flocculation and creaming go hand in hand. The creaming is a phenomena that is seen by the accumulation or the aggregation of droplets or globules of the dispersed phase at the top of emulsion or the bottom of the emulsion. Let's see. This rate of creaming is explained by an equation called Stokes equation or Stokes law. Hope you remember the Stokes law. Did you ever hear about this law from your past semester? Hope you remember this one. Stokes equation in regarding with the suspension, it actually deals with the sedimentation velocity. The same equation is applicable for determining the stability of emulsion also. But whereas here the V represents the rate of creaming, D represents the diameter of the globule or the droplet. Rho S, rho naught determines the density of dispersed phase and dispersion medium. G represents acceleration due to gravity and eta represents the viscosity of the dispersion medium. Do you always remember? Now we are discussing about the creaming and the flocculation. For this, the density differences between the dispersed phase and dispersion media plays really a major role. For example, if we consider oil in water type of emulsion, which is much less denser, oil or water? Of course, oil is less denser than water. That's why it floats on the water, right? So if we are supposed to prepare oil in water type of emulsion, okay, and then if there are any major differences between the densities. If the if the oil phase we have selected is very much way denser, less denser than the water, then there will be some change in this, right? This is the density of the dispersed phase. This is the density of dispersion medium. So if there is a vast difference, there will be a change in the rate of creaming. The density of the dispersed phase means if this is much less denser than the density of the dispersion medium, all the globules will tend to come closer and then tend to float on the formulation. That phenomenon is known as upward creaming. Similarly, if the density of dispersed phase is much greater than the density of dispersion medium, this sedimentation seen at the bottom of the container known as downward creaming. This is mostly seen in water and oil type of emulsions. So do always remember, creaming is a reversible phenomenon. When you tend to observe this kind of instability, and this can be easily reversed by gentle shaking or gentle mixing. So that is how flocculation and creaming go hand in hand. When all the globules tend to come closer and form flocks, and if there are any density differences, then it will lead to creaming, either upward creaming or the downward creaming. So that is about your flocculation and the creaming. Now let's see the next instability parameter is our coalescence and breaking. So the name itself indicates coalescence here is known as fusion. So coalescence is actually characterized by the aggregation of globules or droplets of dispersed phase. The important thing is it is an irreversible phenomenon. Now what is the actual reason behind this? Whereas in creaming, all the globules will tend to come closer, and then they tend to either float or they tend to either get sedimented based on the density differences, right? Whereas here, what could be the reason? So as you all know, emulsifying agents, they act as a barrier, as a film between the oil and the liquid phase. Suppose if in case this barrier is leaky, or if the film that is formed by this emulsifying agents is not strong enough, then it could lead to the rupture of the film, and thus making all the dispersed globules to come closer and fuse together, which is nothing but the coalescence. So here let's use a different terminology in the place of fusion. We'll be making use of a coalescence term in the place of fusion, okay? Because we are professional, right? So now because of the rupture of this interfacial film, it leads to the coalescence of dispersed phase, and thus it leads to breaking up of the emulsion. All the oil phase will tend to come closer, they form a larger globule, and they tend to get separated into different layers, the oil phase and the aqueous phase. Thus, the emulsion is completely broken. That is a irreversible phenomena, and it leads to complete instability. That's the another reason. And the next one is the physical and the chemical changes. And chemical changes, the name itself indicates, where the agents present in the formulation acts as the they either improve the stability or they either decrease the stability. For example, the agents, what are the different agents seen in the emulsion? It could be the oil phase, aqueous phase, emulsifying agents, preservatives, flavoring agents, right? So we are having different ingredients to make up one formulation, especially emulsions. So in this case, emulsifying agents will be using as stabilizers, improves the stability. But in case if the chosen emulsifying agent is of natural origin, like natural gums, starches, they actually lead to bacterial growth, as they are naturally obtained. They act as a source for, they act as a nutritional source for the bacteria. Now what happens if a bacteria grows in a formulation? Of course, it causes a pH change, right? The bacteria will produce toxins, right? And thus there'll be change in the pH, and consequently it will lead to breakdown of the emulsion. The changes in the pH actually causes a change in the chemical constituents present in the emulsion. That is why natural emulsifying agents are replaced by synthetic emulsifiers or semi-synthetic emulsifiers. Mostly to get a stable emulsion, synthetic emulsifiers are used. And again, the important thing we need to note down is, so if we are using emulsifying agents like either cationic or anionic emulsifying agents, we need to be extra cautious, because if any substance that we add, like a preservative or flavoring agent, any agent that we add to make up a formulation, if that added substances neutralizes the charge of the cationic emulsifier, it causes the breakdown of emulsion. You understand? So we need to be very cautious about the substances which we choose during the formulation of an emulsion, because any of the substance can actually neutralize the charge carrying by the emulsifying agent. It could be a cationic or anionic emulsifier. If it neutralizes the nature of the emulsifying agent, then there is no need of, the purpose is not served. That is why we, being a pharmacist, we need to be very extra cautious, and we need to take utmost care in the formulation and maintaining the stability. Right? Now let's see onto the next, the final unstable parameter, phase inversion. The name itself indicates there is an inversion in the phase. For example, if we are supposed to prepare oil in water type of emulsion, okay, oil in water type of emulsion, by making use of sodium stearate as our emulsifying agent. Now, in this formula, if we add calcium chloride, for example, if we add calcium chloride, now this calcium, from the calcium chloride, it reacts with the stearate and form calcium stearate. Calcium stearate is a divalent soap, whereas sodium stearate is a monovalent soap. The complete nature of the emulsifying agent is being changed by adding another agent. So we need to take utmost care by adding different agents. This could actually change the nature of the emulsion. Now this phenomena is better explained by another example. Now let's see what are the different reasons for this phase inversion. The first reason is this phase inversion is caused by the alterations in phase volume ratio. The statement itself clearly explains Let me explain with one example. For example, if we take oil and water type of emulsifying agent, if this agent is mixed with oil and little amount of water. Now, whenever if you come across oil and water type of emulsifying agent, which type of emulsion would it support? Obviously, oil and water, right? So when you mix this emulsifier with the oil and water, of course it will form oil and water. But if there is a little quantity of water and if there is a larger quantities of oil phase when compared to aqueous phase, it supports water in oil, because since the water volume is less, it forms water in oil emulsion. Obviously, the greater proportion of the phase will tend to be the external phase, right? In this case, water is lesser in quantity, so it takes the position of internal phase. Now, for example, if we continue to add water slowly, phase inversion occurs. Now, oil and water emulsion is formed. That's how, phase inversion is produced by alterations in phase volume ratio. This is one reason. The other reason is temperature dependent changes. This reason we already discussed in our practical session. Now, while preparation of an emulsion, most of the emulsions are prepared by heating method, right? We'll be heating oil phase, aqueous phase separately, and then we're mixing up the two phases. And when this is actually cooled at the room temperature. But if this prepared emulsion is exposed to extreme higher condition or extreme lesser temperature, extreme higher temperatures, it will lead to inversion, because this temperature dependent changes actually affects the solubility of emulsifying agents. When you look at the picture, you'll be able to see clearly. See, when there is a rapid cooling, it actually supports oil and water type of emulsion. When you actually heat it, what happens? The aqueous gets evaporated, the aqueous phase diminishes in its quantity, gets lessened. So means what here? As the temperature is being increased, the aqueous phase gets evaporated, the water phase will be reduced, and that will cause an alteration in the phase volume ratio, and of course there will be inversion. That is how phase inversion occurs. Now, in today's lecture, what we have seen the different theories of emulsification. We just brushed up our basics, and then we have seen what are the different instability parameters, like flocculation and creaming, coalescence and breaking, physical and chemical changes, phase inversion, right? We have seen what are the various reasons and what actually happens during this instability parameter. In the next lecture, we'll be discussing about how can we encounter these type of unstable parameters. How can we improve the stability of the emulsion? We being a pharmacist, we need to actually produce, or we need to actually formulate a stable product, right? So in the next lecture, we'll be discussing about what are the different methods to improve the stability, and what are the various rheological considerations during manufacture and packing of the emulsions, right? I hope you like this video, and I would like to tell you something. Why I've chosen this way is because by considering most of the students might not be having 24/7 internet facility, and it is actually really difficult to bring all the students together at the same time. That's why I thought this would be a better idea than a video conference, conference call kind thing. Hope you like this idea, and if you have any doubts, you can actually ask. You can send you can email me. So that's all for today. Hopefully I'll do another video on the next lecture. Okay, meanwhile, take care, stay warm, and enjoy the vacation. Okay, happy learning.